Hi. So I'm going to go over where integration by parts comes from and how we use it to solve integrals as an introduction. So here's an integral. We have the integral of x times sine of 5x dx. All right, so if we go through our list, this is not a simple integral. Right? It's not in our table or knowledge bank. And it is not u substitution. Right? Because if it was u substitution, we'd have an inside function and an outside function. Well, we do have an inside function. And our inside function is 5x, okay, and our outside would be x. Right? And x is not the derivative of 5x, right? So we can't use u substitution here. So we'd be stuck if not for integration by parts. Okay? So we also don't have a rule for a product. Right? There's no general product integration rule. Right? But it turns out we can use the product rule for differentiation, right, to give us a way of dealing with integrals that are more complex, such as this. All right, so if we go over, here's the product rule, right? The derivative of f of x g of x, right? So the derivative of a product is f prime x g of x plus f of x g prime x. Okay, so the derivative of the first function times the second function plus the second function times the derivative of the first function. Okay. So I'm going to make a few substitutions here. Okay, first I'm going to say, all right, that u is equal to f of x, okay, and v is equal to g of x. Whoops. And the reason I'm doing that is because all of the resources you'll see that deal with integration by parts, we talk about a u and a v. Okay, so I'm going to rewrite this now, where we're looking at the derivative of u v dx, right, is equal to, now f prime would be u prime, but instead of writing u prime, I'm going to write du dx times v, to be clear. That's u times v plus, now again we have u times the derivative of dv dx. Right, so that's our product rule. Right? If we're taking the derivative of u times v, the result would be du dx times v plus u times dv dx. Okay? Well, let's remember from the fundamental theorem of calculus, we can invert a derivative, right? So if I just take the integral with respect to dx of both sides, okay, so if I just take the integral dx, the integral of dx. Right, so take the integral of dx for both sides. Now, no one's going to argue that if I take the derivative of u times v and take its integral, I'm going to end up with uv. All right. I should put those in the terms that they're supposed to be in so it's clear what's going on. Right? So we're going to have u v is equal to, now, properties of integrals. Right? We're going to deal with each individual piece. All right, so I'm just going to rewrite it a little bit. So we're dealing with the integral of v, right, because now v is a function, times du dx times dx. All right. Plus the integral of u dv dx. Times dx. Right, now what you notice here is that the dx's in both of those will cancel out. Right, so I'm going to get rid of, right, so I have dx here and dx here and dx here and dx here, and those are going to cancel. Say bye. Right, they go away. Right, so I'll be left with the integral of v du plus the integral of u dv. Right, now to make this useful, right, I'm going to solve for one or the other, and the one that we traditionally solve for, okay, as a connotation, is the integral of u dv. So what I'm going to say is that the integral of the function u times dv. Okay, so that's solving for u dv is equal to the function u times v minus now the integral of the function v times du. Okay? Remember, the dx's up there can cancel, and I've tried to emphasize the dx and du are subject to all of the function opportunities, right? The integral sign is the limit as n goes to infinity of the sum of I equals 1 to n, right, where n is infinity. And then everything to the right of that is the function, right? So the dx, the dv, the dy, they're not inherently tied to the integral. They're tied to the Riemann sum, okay? So if we're doing something to dx, right, it can cancel out. So we get rid of their dx's. And that right there is the basis of our product rule. Of our integration by parts. The integral of u dv equals uv minus v du, okay? So what we're going to do here is we're going to make an equivalence, okay? We're going to say that our function, okay, so if we go over, right, we've got everything in the same window here. All right, we're going to say that our function, integral x sine 5x dx, is equivalent to u dv. Okay, so this is just equal to saying integral of u dv. Okay? So what that means is we're going to look for a piece in our original function to call u, and we're going to look for a piece in our original function to call dv. So that's where we're going to start, right? We're going to look by establishing what is u, okay, and what is dv. Okay? If we look at what is happening, all right, what things are equal to, well, what is u? Okay, and what do we need here? In our problem, we have a u and a dv. Those are known. So the unknowns are v and u. How do we get u? Well, to get du, we need to take u prime, right? So du is u prime dx. Okay, so in this case, what we're doing is we're taking the derivative of u. And that's going into our u substitution, right? Because du is going to get substituted in. All right, so if we're going to take the derivative of it, that means it goes down. Well, let's choose x to be du. So that way we get the du, in this case, right, is just equal to 1 times dx. All right, I'm going to write the 1 there as a placeholder just to remind myself that I actually did something, right? I took a derivative of x and ended up with 1. Well, that leaves everything else to be dv. I know there's a lot of writing, so I'm going to zoom in here just to... All right, so dv here is going to be sine 5x dx. Okay, well now we need v. Well, v is equal to, right, v prime dx. Right? Or the integral of v prime dx, right? dv up there is u prime dx. So that means for v, we just need to take the integral of what we'd established as dv. So the integral of sine 5x dx. Right? So what we're going to get is that v is equal to negative 1/5 cosine 5x. Right? And that's the function. Okay. So now I make all my substitutions into u dv equals u times v. Right? So I start with my integral. I've said that u is x, and dv is sine 5x dx. And that's going to be equal to u times v. So x times negative 1/5 cosine 5x, okay, minus the integral of v now, right, which is minus 1/5 cosine 5x times du, where du is 1 dx. So 1 dx. Okay. So the only thing I have left to evaluate is this integral down here. Now if this integral is simple, right, I can do it exactly. It is not as simple, but I can do it through use substitution, just like I had to do the integral of sine 5x dx. Right? We needed a use substitution up there to find the integral of sine 5x. We need to use substitution down here for the integral of cosine 5x. So now we're left with the integral of x sine 5x is equal to negative x over 5 cosine 5x, right, plus 1 over 1/5 times 1/5 sine 5x plus c. And that's our solution. Okay, so there's places in here where things can get hectic, right? So in my initial solution, if I look to take the integral of v, and it's a complicated integral, I might have to do an integration by parts. I might need a complicated use substitution. I may get to the end and have this integral of minus 5x, need to do another integration by parts, or need a use substitution. And these can get on and on and on and on and on, and we just keep going. And some integrals take pages and pages to solve because you keep having these embedded versions of integration by parts. All right, so go on and watch the next video and see some more examples.